Alrighty, hello class. We're going to go on to 6.5, talking about indirect proof. So to start off our definition of an indirect proof, you're going to use indirect reasoning. So remember, indirect reasoning kind of is like implied or assumed. In this point, nothing is told to you verbatim, and it can always be false. But this is where you're going to make a temporary assumption. So make a temporary assumption that the conclusion is false. So you're going to assume that the truth that was told to you is probably going to be a lie. Or you're going to prove it true by contradiction. Okay, so this is kind of where you're taking, if we remember truth tables, if you have false and false, there's always false. Well, in this case, if you have something you're going to assume that it's false, even though it's true. Okay, so it's a little confusing, but the main aspect is just knowing indirect proof. So something that's not told to you verbatim. So here are your core concept. Step 1 is identify the statement, and then assume that this statement is false by assuming that the opposite is true. So if I told you that my house is on fire, I'm going to tell you that my house is not on fire. And it's a contradiction because you can see it's on fire, and I told you you're going to assume that it's not on fire, so it is on fire. So reason logically until you reach a contradiction, and then point the desired conclusion must be true because the contradiction proves the temporary assumption false. So in this case, false plus a false gives me a true statement. Alrighty, so let's move on to our theorems. Our theorems, we have a triangle longer side theorem. So if one triangle or one side of a triangle is longer than the other, then the angle opposite of the longer side is larger than the angle of the shorter side. Okay, so in this case, across from 5, A would be smaller. So this is smaller than what's across from 8, which is C. And this would be larger. So you're talking about the things that are across from it. So let's say I had an example. I have A, B, and C. And we'll say that I have 11, 13, and 12. And what I'm going to do is I'm going to list the angles of triangle ABC in order from smallest to largest. So looking at this, know that if we're going off the triangle longer side theorem, I know that one side, the angle opposite of my large side, is always going to be what the angle could be. So let's start with the smallest side. So the smallest side is 11. So that means opposite of that smallest side with the angle would be A. So angle A would be the smallest side. Then let's look at our next smallest side, which is 12. And across from 12 is angle B. So B is my next smallest side. And so that means C, or where BA is 13, crossing that is C, which will be my largest side. Okay? So it's always the angle that's opposite of that. Alrighty, let's turn to the next page. Alrighty, moving on to the next section, I have the triangle longer angle theorem. So very similar, but this just tells me that the sides are going to be even more, are going to be longer based on where they are. So that means that AB, which is across from 30, is going to be a short side. And that means BC is going to be the large side. It's going to be larger than this side. We're not sure about AB yet because I don't have an angle measure for it. It is going to be large. So let's try an example. No, it is not drawn to scale, and that's okay. So I have A, B, and C. And so let's say that B is 61 degrees and angle A is 59 degrees. And I need to list sides of triangle ABC in order from shortest to longest. So in order from shortest to longest. So I have A. Anything across from A is going to be fairly long, but what if we found the measure of angle C? So we know that all angles have to add up to give me 180. So let's find this missing angle, and that way I know the order of each of my sides. So I have 61 plus 59, and I get 60, or I get 10, 11, 12, 120, right? And then I take 180 minus 120, and I'm left with 60 degrees. So now I'm able to label the measure of my sides from shortest to longest. So let's go from the shortest angle. So the shortest angle is 59, and across from 59 is line segment BC. And then 60 is my next shortest side, and across from that is AB. And so my longest side would be across from angle B, which is AC. Okay, moving on to the next one, I have triangle inequality theorem. And so the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So I have the sum, so that means add, the lengths of any two sides is going to be greater than the length of the third. Okay, so let's look at an example. And let's say I had 8, 5, and 10 for triangle ABC. So let's check to see all our answers. So I have AB plus BC has to be greater than AC. So AB is 8 plus BC is 5 and AC is 10. And when I simplify, I have 13 is greater than 10, and that does check out. Let's try AC. AC plus BC is greater than AB. AC is 10, BC is 5. Has to be greater than AB, which is 8, and 15 is greater than 8. Then for my last one, I have AB plus B, or AC, is greater than BC. So AB is 8 plus 10 greater than 5, and 18 is greater than 5. So all of these check. Okay? So that's the way of proving these work. And if there at some point it doesn't, it means our measurements are off, or it is not a true triangle. Okay. So on the back side, we're going to skip 1 through 5 at the moment because that deals with more of our indirect proof definition. But we're going to hit 6, 7, and 8, 9, 10, 11, and 12. So number 8 says list the angles of the given triangle from smallest to largest. So let's list our angles. So let's look at from smallest to largest. What is our smallest side? Well, our smallest side is 6. So across from 6 is C. So angle C is the smallest. And then across from 8, that's our next one, is A, so angle A, and then across from 10 is angle B. And then we'll do the same thing for 7. So it's going from smallest, so across from 7 is D, and then across from 15 is E, and across from 18 is F. And for number 8, our smallest one is 11, so across from 11 is H, then across from 14 is J, and across from 16 is G. Alrighty, let's look at 9, 10, 11, and 12. It says, is it possible to construct a triangle with the given side lengths? If not, explain. So let's check. So let's check these two side lengths. So if I were to have 17, so take the largest one, so 17, is it going to be greater than 3 plus 12? So 17, is it greater than 15? No, it is not. So this would be no. Okay, now let's check our largest one. So 21 for number 10. So 21, is it greater than 5 plus 16? So I have 21 greater than 21. 21 can't be greater than 21 because it actually equals that. So this would be a no. I'll choose our largest one, which is 8. So 8 has to be greater than 5 plus 7. So okay, so I have 8 is greater than 12. Well, these two sides is actually greater, so this actually needs to go the other direction. So the two sides are greater than my single side, so this works. This is a yes. And then I pick my longest side, 11. And then I have to deal with 10 plus 3. So 11 is actually less than my two sides, which is 13. So this works. So it's yes. So remember, when you add two of them, it has to be greater than the single greatest side. So that's why this didn't work. And this didn't work because it was greater than what was equal to. Okay. And we'll conclude the notes from here. We'll go over 13 and then 1 through 5 in class. Thank you so much.